In this lecture, I will explain discrete Fourier transform or DFT. Actually, the DFT is a mathematical technique used in signal processing and other fields to transform a finite sequence of equally spaced samples of a function, usually in the time domain function, into a sequence of complex numbers representing the function's frequency components. The DFT is widely used because it allows for efficient computation of the Fourier transform using digital computers. Here, given a discrete time signal x of n of length n, where n equal to 0, 1, 2, 3, n minus 1, the discrete Fourier transform or DFT is defined as x of k equal to n equal to 0 to n minus 1 summation of n equal to 0 to n minus 1 x of n into e to the power minus j twice by n k divided by n, for k equal to 0, 1, 2, n minus 1. By definition of inverse discrete Fourier transform, x of n equal to 1 by n summation of n equal to 0 to n minus 1 x of k into e to the power j into twice by n k divided by capital N. Here x of k represents the DFT of the sequence of x of n at the kth frequency v. N is the number of samples, j is the imaginary unit, e to the power minus j twice by nk divided by capital N represents the complex exponential. Actually, it is the basis function for the discrete Fourier transform. Now I will discuss about properties of discrete Fourier transform. The first property is linearity property. If discrete Fourier transform of x of n is equal to x of k, or discrete Fourier transform of x1n is equal to x of k, and also the discrete Fourier transform of x2n is equal to x2k, then the discrete Fourier transform of ax1n plus bx2n equal to ax1k plus bx2 of k. The periodicity property states that x of n equal to x of capital N plus small n. For equation, if a signal of x of n equal to 1, 2, 3, 4, the position of each value is small n equal to 0, 1, 2, 3. Position, n means position, and the value of capital N is equal to 4. If discrete Fourier transform of x of n is equal to x of k, then discrete Fourier transform of x of n plus small n equal to x of k plus capital N. Now time reversal property. If discrete Fourier transform of x of n is equal to x of k, then discrete Fourier transform of x of minus n or x of n minus n is equal to x of minus k or x of n minus k. That means discrete Fourier transform of x of minus n is equal to x of n minus k. Let a function x of n 1, 2, 3, 4. This is periodic function. If we draw this function, we get, for this periodic function, if we draw, we get this figure, this signal. In 0 position, the magnitude is 1. In 1 position, the magnitude is 2. In n equal to 2 position, the magnitude of x of n is 3. And when n equal to 3, or in 3 position, then the magnitude of x of n is 4. This is repeating again. In 4, the magnitude is 1. In 5, the magnitude is 2. In 6, the magnitude is 3. In 7, the magnitude is 4. That means the magnitude is 1, 2, 3, 4, 1, 2, 3, 4, and it's also repeating in left side. 1, 2, 3, 4 in minus 4, minus 3, minus 2, minus 1 position. This is continuous in from minus infinity to plus infinity. For the time reversal property, x of minus n equal to x of n. That means in 0 position, the magnitude remains always 1. But when in minus 1, n equal to minus 1, the magnitude is plus 4. In 1 position, the magnitude is 2. For time reversal property, in n equal to minus 1 and n equal to 1, the value of magnitude will replace in, that means in minus 1 position, the magnitude of the signal is 2. In minus 1, the magnitude is plus 1 value, plus 1's, n equal to 1's magnitude. That means value is 2, 1. And in 1 position, the value is 4. Now in n equal to 2, the magnitude is 3. That means this value will replace with n equal to -2 values. If n equal to -2, then the value is 3. Minus value is come to plus value, and plus position's value comes to minus position. And when n equal to +2, then the value is 3. In n equal to -3, the magnitude is +2. This value comes to +3, and for the value n equal to 2, and in +3 the magnitude is +4. This comes to -3. In -4 and +4, both magnitude is +1. If the reverse position, both value is 1. That means no change. When n equal to 5 and -5, one's value is 2 and another -5's value is 4. If this replace into one another position, then we get in +5 position the value is 4, and in -5 position the value is 2. When n equal to 6 and n equal to -6, both value is magnitude is 3. That means we get +3, no change occurs. And if we see n equal to 7, the value is magnitude is 4, and for n equal to -7 the magnitude is 2. And if the replace one another position, then in +7 position the magnitude is plus 2, and in minus 7 position the magnitude will be plus 4. That's why we get, that means we get in plus 7 position the magnitude is minus 7 positions, and that is 2. Here is the time reversal property. If xn equal to 1, 2, 3, 4, when the position is n equal to 0, 1, 2, 3, zero, 1, 2, 3, 0, 1, 2, 3 position, the value is 1, 2, 3, 4. And now from the time reversal property we get x of minus n equal to 1, magnitude 1, 4, then 3, then 2, in n equal to 0, 1, 2, 3 position. N equal to 0, 1, 2, 3 position, the magnitude of x of minus n is 1, 4, 3, 2. This is x of minus n. If discrete Fourier transform of x of n is equal to x of k, then if minus L shifting occurs in x of n, then the discrete Fourier transform of x of n minus L is e to the power z twice by kl into x of k. Or we can write this omega n to the power kl. Omega n kl is means phase vector. If we draw a periodic signals, here I draw a periodic signal x of n equal to 1, 2, 3, 4. Here the position is minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, n equal to 4 position, and the magnitude is 1, 2, 3, 4, again 1, 2, 3, 4, again 1, 2, 3, 4. It repeats again and again because it is a periodic signals. And if L equal to 1 shifting in L equal to 1 shifting in right position, then L equal to must be minus 1, and then the figure the signals will be the position is n equal to 0, 1, 2, 3, 4, 5, and in left side the position is n equal to minus 1, minus 2, minus 3, minus 4. As the shifting is minus 1, that means in the signal will shifting in right side. Minus 4 will come to one position in right side. That means in 0 position the value is 4, and in one position, in previous figure, in 0 position the value is 1, and now in 1 position the value is 1. In 2 the value is 2, because this shifting causes in right side, the signal shifting in right sides. The fixed positions value of this signal is shifted to its next position in this new signal. That means for this signal we get x of n minus 1 equal to 0. In 0 position the value is 1, is 0 position the value is 4, 1 2 3, 4 1 2 3, n equal to 0 1 2 3, 0 1 2 3, the value is 4 1 2 3. For -2 shifting, the signal will shifted in right sides in two of places of an previous signals. That means the value is 1. In 0 position that will shifted to 2, 1 2, and in 1 position the value is 2. This will shifted in 3 position. In 0 the value is 1. That means in 2 the value is 1. In 3 the value is 2. In 4 the value is 3. That means we finally get the signal is 1 2 3 4, 1 2 3 4, x of n minus 2 equal to 3 4 3 4, then 1, then 2. In n equal to 0 1 2 3 position. When n equal to -2 amount of shifting occurs in signals, then the signal will shifting in right side in 2 point of places. In frequency shift property, if the discrete Fourier transform of x of n into e to the power z twice by nl divided by n is x of k minus l, then we get this type of Fourier transform, discrete Fourier transform. And for the complex conjugate property, we get this type of discrete Fourier transform. If discrete Fourier transform of x of n is x of k, then conjugate of x of n, the discrete Fourier transform is conjugate of x of minus k. In convolution property, we get this type of Fourier transform. And this is multiplication property. For the Parseval's theorem, the energy of the sequence in the time domain is equal to the energy in the frequency domain. Here is the time domain in energy, and here is the frequency domain in energy. In correlation property, the cross correlation of two sequences can be computed using the discrete Fourier transform as r of xy m is equal to inverse discrete Fourier transform of conjugated of x of k into y of k. Here's I ending the video. This is the basic concept of discrete Fourier transform. Thank you.